All right, now we're on to difficulty 2 problems. Now here's where things start to get a little bit more challenging, but the method that we are going to use is exactly the same as what we've used previously in all the difficulty 1 examples. So now notice what we have here is we have x to the 4th, which is a little bit different from the last set of examples, plus 2x squared plus 1. Now I posit that this is going to be the exact same method, we're going to use the exact same method here, but we're going to need to do a little bit of substitution first. What does that involve? Well, I noticed firstly that like in a previous example, like when we looked at say x squared plus 10x plus 25, it was x squared plus x. So x has half the power of this x squared. Here, if we look at this example, we have the exact same situation. We have half the power on this variable expression here as compared to this one. So maybe I can change this so it looks more like this, more like stuff with squareds in it that I know how to deal with. We're going to use a method called substitution for that. So what are we going to do? I'm going to let y equal x squared. Now every place I see an x squared, I'm going to replace it with a y. So now x to the 4th plus 2x squared plus 1, well that's just equal to x squared squared plus 2x squared plus 1. And then that is equal to, based on our substitution here, we're going to replace everything that every time we see an x squared, we're going to replace it with a y. So this becomes y squared plus 2y plus 1. All right, now if we're on the same page, this looks a lot like a previous example we did in the difficulty 1 section. And the problem remains exactly the same. So we need two numbers that add to 2 that multiply to 1. Okay, so again, look at the factors of 1, which is just 1 in itself. Do those add to give us 2? The answer is clearly yes, so we put 1 and 1 and 1 and 1 up here. So now this factors as y plus 1 times y plus 1. But here's the thing, we're not quite done yet because we made this substitution with y is equal to x squared. We wanted a factorization for this guy, not this weird thing that we came up with. So how do we get it? Well, we substituted out every place we saw an x squared, we replaced it with y. We're going to do the opposite now. What does that entail? Well, every place I see a y, replace it with an x squared. So you have x squared plus 1 times x squared plus 1. Now that we have our x's back in place, this thing is completely factored. These things do not factor any further. They are what are called prime polynomials. So we're done at this point.